This is our last lesson, and our focus in this entire lesson is double and half angles, but the first part is only going to incorporate the double angles. So let's go ahead and get started. Our double angle formulas, you do already have them listed, but we like to jot them down so we can reference them as we need. Our double angle formulas go sine of 2x is 2 multiplied by sine of x multiplied by cosine of x. And remember that x represents the original angle. Okay, and then cosine of 2x has its own formula. So cosine of a double angle is cosine squared of x minus sine squared of x. Alrighty. Our first example is on the unit circle, which means when it's on the unit circle, it's really easy. If we know the original angle, then all we have to do is double that radian or double that degree and find that value on the unit circle, and we're done, okay? But we're gonna practice using the formulas. So for number one, suppose x is between 90 and 180 degrees, that's quadrant 2, and sine of x is 1/2. Okay, so where on your unit circle does your y value equal positive 1/2 in quadrant 2? Correct. That is at 150 degrees or at 5 pi over 6. So I need to know sine of 1/2, and I also need to know cosine of 1/2 in order to use both of these formulas. Excuse me, not sine of 1/2, sine of 150 or 5 pi over 6. Excuse me, guys. Sine of the angle 150 degrees is 1/2, and we need to know cosine of the angle 150 degrees is negative square root 3 over 2. Now, sorry for the mix-up, let's continue on. To determine sine of 2x, sine of 2 times 150, what are we doing? We're doing sine of 300, that's right. Now, again, you can find that on the unit circle and boom, you're done. But this is to kind of get you recognized with the formula. So it's 2 multiplied by sine of the angle 150 multiplied by cosine of the angle, the original angle 150. Okay, so that's going to give us 2 multiplied by 1/2, that's sine of 150, multiplied by negative root 3 over 2. All right, 2 times 1/2 is 1. 1 times negative root 3 over 2 is negative root 3 over 2. So sine of 2 times 150 degrees equals negative root 3 over 2. All right, find it on your unit circle. Check. Make sure that that's a true statement. Okay. All right, next one, cosine of 2x. So what is cosine at 300 degrees? Cosine of 2 multiplied by 150, or you can write 5 pi over 6, that's fine. That's going to be cosine squared of 150 degrees minus sine squared of 150 degrees. Okay, we know cosine squared is negative square root 3 over 2 squared, and we know that sine is going to be 1/2, so sine squared is going to be 1/2 squared. All right, guys, when we square things, we square the numerator, square the denominator. Great. So negative root 3 over 2 squared gives me a positive 3 over 4. 1/2 squared gives me 1/4. When I subtract them, I get 2/4, which means that cosine of 2 multiplied by 150 degrees should have a value of 1/2. Promise if you look on the unit circle, it does. All right, our next example, this one is not on the unit circle, so we will do a little bit more work just to make sure that we're good to go and that we got everything we need. Alrighty, so in number 2, we have sine of x is 3 over 4. X terminates, that's our angle, in the first quadrant. That's kind of nice. And then find sine of 2x and cosine of 2x. So in quadrant 1, I go to the right, up, and then back down. There's my angle. The y is 3, hypotenuse is 4. This is not a 3, 4, 5. Eek! That's okay. Do a little bit of Pythagorean theorem. Sine of x is 3 over 4. So x squared plus 3 squared equals 4 squared. So x squared plus 9 is 16. X squared equals 7. So x equals the square root of 7, meaning our x horizontal distance is square root of 7. Therefore, cosine of the angle x equals the square root of 7 over 4. Great. Now we can do both sine of 2x and cosine of 2x. All right, so sine of 2x is 2 multiplied by sine of the angle multiplied by cosine of the angle. 2 multiplied by 3 over 4 multiplied by the square root of 7 over 4. Alrighty. So that's going to give me 6 multiplied by the square root of 7 over 4 times 4 is 16. And that simplifies. You can simplify the 6 and the 16 to give you 3 square root 7 over 8. Okay. Cosine of 2x is going to be cosine squared of x minus sine squared of x. Cosine is the square root of 7 over 4, so I'll square that value to give me 7 over 16, minus sine is 3 over 4, so I'll square that value to give me 9 over 16. And 7 sixteenths minus 9 sixteenths is negative 2 sixteenths, or negative 1/8. That is cosine of this double angle. Okay, good job. All right, number 3, find the exact values given cosecant of theta is 5 over 3 and secant of theta is negative. Okay, so let's process. Cosecant of theta is 5 over 3. It is the reciprocal of sine, so sine of the angle would be 3 over 5. Secant is negative, and its reciprocal is cosine, therefore cosine would also be negative. So where is sine positive and cosine negative? That's exactly right. We are back in quadrant 2. So there's my theta. Sine is 3 over 5, opposite over hypotenuse. Therefore, this is a 3, 4, 5 Pythagorean triple. My cosine value is going to be negative 4 over 5. Cosine of theta equals negative 4 over 5. Alrighty, find cosine of 2 theta. Cosine of 2 theta equals cosine squared of the angle minus sine squared of the angle. Cosine is negative 4/5, so I'm going to square that value and then subtract. Sine is 3/5, square that value. Negative 4/5 squared is 16 over 25 minus 3/5 squared is 9 over 25, which gives us 7 over 25 for cosine of 2 theta. Okay, now find secant of 2 theta. Guys, we didn't write a formula for secant, but you know what? We don't need to, because we already know that secant and cosine are reciprocals. Therefore, secant of 2 theta is just going to be the reciprocal of what we got for cosine. So secant of 2 theta will be 25 over 7. We got it. There we go. See, it wasn't that bad. Alrighty, last 2 examples for the double angles. Use the double angle identity to find the exact values of cosine squared of pi over 8 minus sine squared of pi over 8. That is our number 5 example. Alrighty, what did they give me? Okay, so let's look at our formulas again. Sine of 2 theta is 2 multiplied by sine of theta multiplied by cosine of theta. And then cosine of 2 theta is cosine squared of theta minus sine squared of theta. Okay, so number 5, cosine squared of an angle minus sine squared of an angle, that looks like what we have in our cosine formula. So I'm going to say that, guys, that's just the expanded version of our cosine formula. Okay, so I know it's got to be the cosine formula, and I know that it is a half Nope, excuse me, it's a double angle. What am I saying? It's the double angle. And I know that the original angle is pi over 8. That's what they gave me. So I know that that's what it's got to be. Okay. Alrighty. Now, you don't have to write all that stuff. That's just kind of like thinking through. Therefore, I'm going to condense cosine squared of pi over 8 minus sine squared of pi over 8 to be cosine of 2 multiplied by the angle. Cosine of 2 theta, and our theta is pi over 8. Well, that gives me 2 pi over 8. Well, 2 pi over 8 is the same thing as pi over 4. Cool. What's cosine of pi over 4? Yep, you know it. The x-coordinate at pi over 4 is the square root of 2 over 2. It's not meant to be hard. We can make it hard, but there's no reason for that. All right, next chunk. Let's do example 6, last one. Sine of 22.5 degrees multiplied by cosine of 22.5 degrees. Okay, again, that one is looking a lot like 2 sine of theta cosine of theta. So this is the sine formula for a double angle, and the original angle that they give us is 22.5 degrees. Okay, so let's use that info. Sine of 2 theta is going to be 2 multiplied by 22.5 degrees. So that will give us sine of 45 degrees. Hey, that's an easy one. It's the same thing as cosine of pi over 4. The x and y coordinates are the same at 45 degrees or at pi over 4. So sine of 45 degrees is square root 2 over 2. Great job with this little bitty lesson. Again, make sure you guys are practicing and let me know if you need anything.